Okay, for this example we're going to do repeated applications of the difference of squares formula. So recall that if a squared minus b squared factors to be a plus b, a minus b. Difference of squares. Okay, so here's our example. X to the fourth minus y to the fourth. First thing I'm going to do is make it fit the formula. So the squared minus the squared. So squared minus squared. Ask yourself, what would you square to get x to the fourth? And the answer is x squared. Because squared squared you multiply, and that's 4. Likewise, you'll get y squared squared for y to the fourth. Now this is like our a and our b in the formula above, so it becomes a plus b, a minus b. Now this is called a sum of squares, and a sum of squares doesn't factor. But over here, notice that we have a difference of squares again, so we're going to apply the formula above a second time. So this is our a and this is our b, so this factors to be x plus y, x minus y. And that's the factorization. Okay, let's try another problem here with some numbers in it. So imagine that you have 16z squared fourth minus 81. Now, again, I'm going to ask myself, can I write this in the formula of a difference of squares? So what squared would be 16z to the fourth? Well, 4 squared is 16, and then z squared is z to the fourth. And 81 is 9 squared. So this is like our a and our b. 4z squared plus 9, 4z squared minus 9. Now this is a sum of squares and it doesn't factor, but this will be a difference of squares. So off to the side here, again I'll practice right in, this is squared minus a squared. What squared is 9? 3. And then what squared would be 4z squared? And the answer is 2z quantity squared. So we're now ready to factor one last time. This is the difference of squares, our a and our b, and so this will become 2z plus 3, 2z minus 3, and that will be the factorization.